Welcome my YouTube channel Math Tutorial. Today discuss three topics from complex number: conjugate of complex number, argument and polar representation. And any other every topic very easily discussed from my first video complex number part 1. Today discuss conjugate of complex number, argument of complex number, polar representation of complex number. First conjugate of complex number with properties. Conjugate of complex number. What is conjugate of complex number? Suppose z equal to a plus ib is the complex number. Then a minus ib is called conjugate complex number. Suppose a plus ib is the complex number, then a minus ib is another complex number is called the conjugate complex number of z. This is represented by z bar. First property z, this is the conjugate complex number. Where we discuss with properties. Conjugate complex number has properties. Z bar equal to a plus ib, z bar equal to a minus ib, complex conjugate complex number of z. Z bar next, that's mean this equal to a plus ib. This is the conjugate complex number, another conjugate than a plus ib. That's mean z bar. That's mean z. This is the z conjugate complex number, another conjugate for reduce firstly tends to z. First property. Second property very easy, z1 plus z2, add of two complex number and conjugate equal to z1 conjugate plus z2 conjugate. Very easy proof. Let z1 is the complex number a plus ib and z2 is the complex number c plus id. Add and conjugate. This is the second property. This is the first property. This is the second property. Third property. Suppose third property z1 into z2. The multiplication of complex number, then conjugate equal to z1 complex into z2 conjugate. The conjugate z1 conjugate into z2 conjugate. Number 4, z1 into z bar. This is the z bar. This is the fourth property. Complex number and conjugate multiplication. This equal to modulus square. Modulus value. Z in modulus value square. This is the fourth property. And fifth property, z1 divided by z2, then conjugate equal to z1 conjugate divided by z2 conjugate. This is the fifth property of the complex number. First, second, third. This is the conjugate of complex number with properties. Next I discuss the argument of the complex number or polar representation of complex number. Polar representation of complex number. Suppose we know that z equal to x plus iy. This is the Argand diagram or complex plane. Suppose P, this is the xy point. Polar representation of complex number. P is any point, then z equal to x plus iy is the complex number. So this is the x real axis and this is the imaginary axis. Then I draw a line, perpendicular line through P and perpendicular to OX real axis, and we draw the line OP. This PXY is the Cartesian coordinate and P R theta is the polar coordinate. So we know that this is the theta and this is the R and this is the X and this is the Y. Polar representation of complex number. তাহলে ওই সাপোজ তাহলে x ইকুয়াল টু मतलब cos theta equal to x by r, cos theta equal to x by r, base by hypotenuse, sin theta equal to perpendicular by hypotenuse. This is the two relation 1 and 2. Put this value z equal to x r cos theta plus y r sin theta. So that's mean r cos theta plus I sin theta. This is the polar representation of complex number. This is the polar representation of complex number. Next, where r equal to this is the hypotenuse x square plus y square. Theta is the argument. Next, define amplitude or argument. This is the 1 and 2 equation. The value of the angle theta which satisfy the argument of definition of argument z. Definition of argument z. The value of the angle theta which satisfy both the equation, both the equation 1 and 2, each called argument of z. Very important definition. The value of the angle theta which satisfy the equation 1 and 2, both the 1 and 2, each called the argument of z, or amplitude of z. We see that amplitude has infinite number of amplitude infinite, but principal value of argument. If theta lies between less equal to pi greater than minus pi, this range, if theta lies between this, then this theta is called the principal value of amplitude. This is the principal value of argument z. If theta lies between this range, then called principal value of argument. How to find the principal value? Principal value very important. Just fourth formula are remember. Then principal value are very easily find. Just fourth formula are remember. Then we solve the argument, principal value of argument. Suppose position of P, this one position, or this. অর্থাৎ first quadrant, second quadrant, third quadrant and fourth quadrant. Okay, first quadrant, second quadrant, third quadrant and fourth quadrant. তাহলে argument set of first quadrant, if z equal to x plus iy, position is first quadrant. then the principal value অর্থাৎ argument z equal to tan inverse y by x. This is the first quadrant. If z equal to x plus iy lies on first quadrant, then the principal value of argument z is tan inverse y by x and theta always this range pi by 2 greater than 0. This is the very important first quadrant. The first quadrant is it. Second quadrant, if the complex number z equal to x plus iy, second quadrant, x negative y positive, z equal to x plus iy. Suppose I write, suppose 1 z equal to x plus iy is the first quadrant, and argument z equal to tan inverse y by x and theta lies between pi by 2 and greater than 0. This is the first quadrant. This is second quadrant. Suppose z equal to minus x plus iy. The argument z equal to pi minus tan inverse y by x. This is the formula for the, if the z lies on second quadrant, then argument z equal to this. Theta lies between pi by 2, lies between this. This is the third quadrant. Sorry, second quadrant. Third quadrant. Suppose z equal to this third quadrant. Suppose minus x minus iy. Then argument z, principal value of argument z equal to minus pi plus tan inverse y by x. Theta lies between minus pi by 2 greater than minus pi. This is the third quadrant formula of find the argument z of z. Lastly, finally, fourth quadrant, z equal to x positive minus iy. Then argument z equal to minus of tan inverse y by x, minus of tan inverse y by x. Very important. And theta lies between less than 0 greater than pi by 2. This is the very fourth formula for fourth quadrant of the complex number. Find the, suppose the given complex number is second quadrant, then find the principal of argument z is pi equal to tan pi minus tan inverse y by x, and theta lies between this and a theta, third and fourth. This is the very important formula, very easy, please screenshot it. Then this is the fourth formula for find the argument z. First quadrant, second quadrant, third quadrant and fourth quadrant. Example, suppose z equal to 1 plus I, x equal to 1 and y equal to 1. This is the first quadrant. Tale apply the first formula, that's mean argument z equal to tan inverse 1 by 1 equal to tan inverse tan pi by 4 equal to pi by 4. Pi by 4 lies between 0 and pi by 2. That's mean principal value of the complex number. Pi by 4 is the principal value or principal value of z, argument z, principal value of argument z. Similarly, we saw that suppose z equal to minus 1 plus I. So that's mean minus 1 comma 1. This is the minus 1 comma 1, this is the second quadrant. We apply this formula and find the principal value of argument z. Finally I give an example and end the video. Finally give an example. Suppose write modulus amplitude form of the complex number. Write modulus amplitude form of the complex number root 3 minus I. Root 3 minus I. Write the modulus amplitude form of the complex number root 3 minus I. Answer. তাহলে z equal to আমাদের root 3 minus I. That's mean point root 3 and minus 1. That's mean x equal to root 3 and y equal to minus 1. X equal to root 3 and minus 1. That's mean this is position is fourth quadrant. So mod z, that's mean r equal to root over of root 3 square plus minus 1 square, that's mean root 4, that's equal to 2. This is the modulus value, and theta equal to principal value of argument theta equal to fourth quadrant minus tan inverse y by x minus tan inverse y by x, y root 3 by y by x 1 by root 3. Minus tan inverse 1 by root 3 pi by 6, 10 pi by 6 equal to minus pi by 6. This is the principal value of argument. We know that z equal to r of modulus polar form r of cos theta plus I into sin theta. That's mean r cos of theta minus pi by 6 plus I into sin of minus pi by 6. That's mean r of 2 of cos of pi by 6 minus I of sin of pi by 6. This is the polar representation of complex number. So end this video. Please like, comment and subscribe. Please like, comment and subscribe my channel.